Hello, welcome to 5.3 Day 1. Today we're going to learn about composite and cofunction properties. Now, to start this off, if we look at cosine of cosine, sine, and tangent of negative theta. Uh, First, let's look at cosine. This is the cosine function. And if I move to the right a certain amount, call that theta. And if I move to the left that same amount, that would be a negative theta. If we look at the y values up here, notice that the y value here and here would be the same value. So the cosine of negative theta is going to give you the same value as the cosine of theta. And you could do it on in these two quadrants. So if this is theta and this is negative theta, their cosine, say, you could pick any number, x, and the hypotenuse would be the same here. So x over that h, those are going to be equal. So cosine of theta is equal to the cosine of negative theta. Now when we move to sine, say if I say this is theta and this is negative theta, the y values are not the same values. They're actually the negatives, or the opposite. So it would be negative sine of theta. So if I have the sine of theta and sine of negative theta, I guess I could have left that up before. If we have x, this right here is going to be negative x. So it's going to be x over 1 or negative x over 1. So this would be negative sine of theta. Now with tangents, we'd need to, when it would have been smarter to you could call this y and negative y and call that x. Tangent would be y over x, and the tangent of negative theta would be negative y over x. So this would be equal to the negative tangent of theta. So if I go out a certain amount to the right, and go out that same amount to the left, these values will just be the positive and negative of the same numerical value. So since cosine of theta is equal to cosine of negative theta equals cosine of theta, sine of negative theta equals the sine of negative sine of theta, tangent of negative theta is the negative tangent of theta. We have the same rules with the secant. Secant follows the same rules as cosine, so it would just be the secant of theta, and both these would be the negative of the trig function. So here are 6 new rules. Alright, now we're going to take a special look at these values. So take out a calculator, and if I found the cosine of 70, that would be 0.3420. If I found the cotangent, I would do 1 divided by the tangent of 70, and that's 0.3640. Cosecant is 1 over sine of 70. That's 1.0642. Alright, now if I find the sine of 20, that's 0.3420. The tangent of 20, 0.3640. Secant is 1 over cosine of 20, 1.0642. Now what do you notice about these two numbers, the cosine of 70 and the sine of 20? Hopefully you're screaming, they're the same number! The cotangent of 70 and the tangent of 20, and the cosecant and the secant. Now this is only true if 70 and 20 add up to 90 degrees. So in general, we say the cosine of 90 minus theta is equal to the sine of theta, and in radians, we say pi over 2 minus x is going to be the sine of x, because we could do this in radians as well. Now, the reasoning for this, if I went down further, if I drew a nice right triangle, and in my right triangle, I'm going to, even though this doesn't look like 20 and 70, let's just use it to match what I was doing above. Let's call this A, B, and C. Now, if I look at the sine of 20, the sine of 20 degrees is going to be B over C, because it's opposite over adjacent. Also, the cosine of 70, since 70 is right here, is going to be B over C. So you can see that those give you the same values as long as these two add up to 90. All right, and those work with cotangent and tangent. Cotangent of 70 is B over A, tangent of 70, or tangent of 20 is B over A. And the last one it works with is cosecant and secant. So cosecant of 70 is C over, did I say cosecant is C over A? So secant of 20 would be C over A. So you get the same values. Somehow I moved that out. All right, let's keep going. So these are what we call the cofunction properties. Now, it looks like there's a ton of properties that you need to memorize, but they're actually the same. This is just the reverse of this, and there's actually a lot more if we throw in radians. I could say cosine of theta is equal to the sine of pi over 2 minus x, and then I could put a pi over 2 for each of those and make it look like there's 6 different equations, but so 12 in all. But as long as you know these three, and you can flip-flop your sines and cosines, tangent, cotangent, secant, cosecant, these three are all you pretty much have to know. All right, so now we're going to do some proofs. We're going to prove that, we're going to find out what cosine of A plus B is going to equal. We know the cosine of A minus B is this. So we could say that the cosine of A plus B is the cosine of A minus negative B. Minus a negative is, if you're subtracting a negative, that's the same thing as addition. So when this is a subtraction sign, we can expand this to look like that. So it would be cosine A cosine negative B plus sine A sine negative B. Now we learned that the cosine of negative b is the same thing as the cosine of b. So I can just fill that in. The sine of negative b is the same as the negative sine of a, so that would just flip this sign to a negative. And now I have a new formula. The cosine of a plus b is cosine a cosine b minus sine a sine b. And we're done with our proof. Also, we can figure out what the sine of a minus b is by using the cofunction property. We know sine is the same thing as cosine of 90 minus this angle. So, so now we can say that this is the same thing as cosine of 90. If I distribute this negative, it's going to be minus a plus b. Now we have three things here, so let's say 90 minus a is the first part of this. So when I expand this with an addition sign, I have cosine 90 minus a times cosine b minus sine 90 minus a times sine of b. Now, when we know cosine of 90 minus a is sine of a, and we know sine of 90 minus a is cosine of a. So now we have a new rule that the sine of A minus B is equal to sine A cosine B minus cosine A sine B. And I am finished. Alright, now we have the sine of A plus B is equal to this, and we want to prove that. Now we can prove that because we have the sine of A equal, we'll prove it the same way. The sine of A minus negative B, that's going to be the sine of A times the cosine of negative B minus the cosine of A times the sine of negative B. Again, the cosine of negative B is the same thing as the cosine of B, and sine of negative B is the same thing as negative sine of B. So negative times a negative would make that a positive. And now we have this function, or this equation. We can flip-flop we can switch these, the positions of those to make it the same, but this is essentially the equivalent to that. Alright, now if I say show by numerical example that this is true, you pick any numbers for A and B. So let's say the sine of 50 minus 20 we want to show is the same as sine of 50 times the cosine of our B, which is 20, minus the cosine of A, which is 50, times the sine of B, which is 20. So this is sine of 30. Sine of 50 times the cosine of 20 is 0.7198 minus cosine 50 times sine 20, which is 0.2198. So the sine of 30, that equals 0.5. And does this side equal 0.5? Well, it sure does. So that shows that 0.5 is equal to 0.5. So the sine of A minus B is equal to sine A cosine B minus cosine A sine B. Now we want to prove that this identity is true. Well, if we start with this left-hand side, we can expand this to be cosine x cosine pi over 2 plus sine x sine of pi over 2. Now on our unit circle, pi over 2 is up here, and that coordinate is 0, 1. 0 is the cosine, 1 is the sine. So what we're saying here is we have cosine of x times 0 plus the sine of x times 1. 0 times anything is going to equal 0. 0 plus the sine of x will just be the sine of x. And we are done. Alright. Now try this one on your own and see how well you do. What we do is we expand these. So this is like sine of A plus B and cosine of A plus B. So this is going to be sine of theta cosine 30 plus cosine of theta sine 30. Now that's just the first section. Now if I expand this cosine theta plus 60, that's going to be cosine theta cosine 60 minus sine theta sine 60. Alright, so now I'll draw a 30, 60, 90 triangle up here. That's 30, 60, 90. And hopefully you know the sides of a 30, 60, 90 triangle. 1, 2, root 3. So the cosine of 30 is root 3 over 2. So that's root 3 over 2 sine of theta. Sine of 30 is 1 over 2, so that's 1/2 cosine theta. Plus cosine of 60 is 1/2. That's multiplied by a cosine theta. And sine of 60 is root 3 over 2. So that'll be minus root 3 over 2. sine of theta. Now we look for like terms. We have a sine of theta and a sine of theta. Well, that's root 3 over 2 minus root 3 over 2, which will go away nicely. And now our cosines, half cosine plus half cosine, is 1 full cosine. And we are done with our proof. All right. Now we have this monster proof, or this monster identity. It looks just impossible. But if we look at this, this is just in the form cosine A cosine B plus sine A sine B. And so once you notice that, it makes this whole thing a lot easier. Because this can be reduced to cosine of 10x. Notice how this is, since that's an addition sign, in cosine this would be a subtraction. This is in the form of cosine of A minus B. That's how we would expand or bring back this. So 10x minus 6x is just 4x. So we got from that to this in 2 easy steps, cosine of 4x. All right, another one that looks pretty tough. We have cosine A cosine B plus sine A sine B. That's going to be the cosine of A minus B. And when I square that, that's like saying cosine squared. Now if I add to that sine A cosine B minus cosine A sine B, that's the same thing as sine of A minus B. This right here is the formula for sine of A minus B. So when I square that, that puts the square there. Now cosine squared plus sine squared of any angle, as long as these are the same thing in the parentheses, is always equal to 1 from our Pythagorean properties. So we, in 2 steps, we got from this gigantic thing all the way to 1. And we are done. All right, that's the end of our lesson. Here is your homework. Good luck.